quite know how to follow an intro where the MCs mowed down my audience with laser-like precision. So I'm just going to launch into the talk. A little bit about me. I think I just got a good intro. I'm a security engineer at Google. Some colleagues and I wrote a roadmap for Node.js Security about where Node is security-wise and how we can get to a better place. I'm not going to be talking specifically about Node today. I'm also represent Google to the JavaScript language committee sometimes, where I mostly talk about the security consequences of programming language design decisions. Today, I'd like to share with you some lessons we've learned about how to hack libraries, tools, and programming languages to make it easier to produce secure and robust software. So I hope to convince you that these practices are key. First, you have to work close to the code. You're not going to achieve a high level of security by working at a distance. And second, if you're redesigning code to address a security problem and you realize you need to make a new kind of distinction, maybe a distinction between a trusted value and an untrusted value, then you should try to represent that distinction in code by having a distinct types for those two kinds of values. And third, you should be safe by construction. If you trust a value, you should be able to explain why it's trustworthy by talking about how that value came to be, instead of talking about how that value is used, which changes a lot over time, or about parts of that value, because the parts of the value are each isolated in context. And these practices only work really well if you can apply them consistently, so adoption is key. It's kind of counterintuitive, but we found that continuous integration tools can actually really help to drive adoption of good engineering practices. So I'm going to start off with a case study of how not to do security. Content security policy. Content security policy aims to solve the largest and oldest web security problem, and still one of the largest. So XSS. How do you make sure that the code that your web application runs is the code that you want to run, instead of code that serves an attacker's purposes? So a colleague of mine, Eduardo, I think summarized how a lot of us in the web security community felt in 2009. So he was really excited about CSP. He thought it was going to be awesome. We had this huge problem, XSS. Nothing was really solving it at scale. This was going to solve it. And the way I'm on strike, I'm not using diagramming tools anymore, so you're going to have to put up with things that I drew down and then shot on my phone. So the way CSP works is you specify a policy in a header. So you specify content security policy header on your HTTP response. The browser grabs that. All your response body goes into the document. But CSP doesn't care about your code. It treats it, it just assumes, it's a bunch of funny punctuation, maybe some silly words. The CSP doesn't need to worry about that. It's going to sit on this pipe between the document and the browser internals. So if you try to load code from a source, that URL goes over a pipe before it's actually fetched. CSP applies. And CSP can veto those URLs. It says, don't load script from this source. If you're loading a script from a chunk of the HTML input, it can similarly block that before it gets to the JavaScript parser. And so this seems really robust. All code loads have to go through CSP before they reach the place where they can have an effect. So any time that XSS happens, it has to be because the policy was wrong. So we've managed to turn the problem of solving CSP into the problem of crafting policies. And after a little bit, we started finding holes in it. And so Eduardo, one day a friend of his pointed out that it could be bypassed using JSON-P. So if you whitelisted an origin, let's say everything from my origin, I'll allow loading as code. And then you provide JSON-P APIs on the same origin, and you let an attacker specify which function to call with the JSON, then the attacker can can work around your CSP policy. So after a little bit of time, we thought that after the JSON-P thing, that maybe CSP isn't bulletproof, but we can still really use it to get a handle on this problem. The workarounds are going to be the exception rather than the rule. So XS is still the top vector. People start looking into, it's been out long enough, are people adopting it? Adoption has never topped 10% of the web for CSP, which means that CSP is irrelevant for 90% of the web. As one data point, Gmail, which layers just about every defense mechanism you can think of somewhere, still has not fully adopted CSP. And then some colleagues of mine wrote a paper, CSP is dead, long live CSP. They went and they did a fairly exhaustive survey of policies out there to figure out how are people using it. Their takeaways were pretty damning. So 99% of hosts use policies that offer no benefit against XSS. Maintaining a secure whitelist for a complex application is infeasible in practice. So CSP, remember, if any XSS, since it sits on the pipe between application code and the browser internals, any XSS has to be a result of a policy failure. And so it seemed that people weren't writing good policies. So they suggested a way to come up with simpler policies. Instead of listing all the sources you want to allow and having to trade off between having a narrow policy that's secure and having a short policy that's maintainable, just generate an unguessable number, a nonce. That's your policy. Then CSP can no longer quite ignore all the details of your HTML. You now add nonce attributes to script and style elements. And that really locks things down. Now, any XSS, since CSP sits on the pipe between your application code and the browser internals, any XSS violation has to be a result of a failure to put nonces in the right place. And you're just putting them on script and style tags. How hard can that be to get right? So since then, Sebastian Lakey's, a colleague of mine, has cataloged 29 different bypasses. Most of these were fairly application-specific, so not something that an attacker could use to bypass CSP on an arbitrary site. But then Sebastian and others did some more research and wrote the Script Gadgets paper, Code Reuse Attacks for the Web. And they found that modern client-side frameworks often include functions that can be turned against the applications and bypass things like CSP. So they concluded, as a result, we assume most mitigation techniques in web applications written today can be bypassed. So even with nonces, modern web application frameworks are vulnerable. So CSP isn't useless. I'm not saying don't use CSP. CSP is a good defense in depth. It stops some things very well. So if you have it and other techniques, then you're in a better place than if you only have those other techniques. But CSP is unlikely to ever solve XSS. It protects few pages right now. It hasn't adapted to client-side frameworks, so it hasn't really aged well with the web. And we really don't know whether gaps in CSP are being fixed by browsers faster than they're found by security researchers. It does solve some non-XSS problems, so definitely still keep it on your list of things to add to an application, security-sensitive applications. And so, in my view, the problem with CSP is that it's sitting outside the application. This is a good place to sit to intercept all requests to load code, but it simply doesn't have the context necessary to make good decisions. This is why these policies don't work. So my first takeaway is if you're doing security, you need to live close to the code, where you can preserve intent. And for the purpose of this talk, I'm defining security in terms of preserving the developer's and users' intent, even when attackers control some of the inputs. So one way to do this is to make sure that important distinctions are represented in the language. And I said, when you've got an important distinction, represent it using distinct types. And so types are like holes in this board. They describe the shape of values that can go through and reach sensitive functions and APIs. So if you're doing something like this, please don't. This function takes any old string and assigns it to inner HTML. If you have an API like this, eventually, if an attacker-controlled string doesn't reach it, you probably just got lucky. Instead, we can use type checks. So HTML might be a string. It might be an instance of type trusted HTML. If it's trusted HTML, then we know that it ought be something that is safe to render in the current origin. That's the contract of trusted HTML. Trusted HTML wraps a string and asserts that it's safe to render in the current origin. And security engineers like me can use some tricks. We can tweak the trusted types proposal that's before the Web Incubator community group. Tweaks prototypes like HTML element.innerHTML setter to check that HTML is trusted type, or try a fallback strategy to coerce it to something that is safe to run in context. So this, if it's a plain old string, it'll fail safe. If it's trusted HTML, it'll just work. And we've got polyfills for that. So once you're checking on critical code paths that values that you trust are trustworthy, you need to make sure that you're only producing trustworthy values of those types. So checking that something is trusted HTML doesn't do any good if being trusted HTML doesn't mean anything. So one of my coworkers wrote up our experiences a couple years ago for the ACM, and his takeaway was that by using these design patterns, you can find the potential for XSS bugs to a small fraction of an application code base, a small fraction that you can then thoroughly review. And so in our experience, the number of pieces of code that need to actually create values that are of one of these contract types, something like trusted HTML, are fairly small. For example, a templating language produces HTML. If you've got an auto-escaping template language, then you know that unless the developer is going out of their way to do something, they're safe against certain attacks. So I maintain the Clojure templates templating language. It's aware of trusted HTML. So if a trusted HTML value makes it here, it's just inlined. If a trusted URL value makes it here, it's just inlined. If a string makes it here, it's auto-escaped so that it's treated as a text node by the parser. If an arbitrary string if a string that reaches here that starts with HTTP, we let it go. If it starts with JavaScript : we're going to reject that. And applying this template gives you back a trusted HTML value that you could then assign to inner HTML. This works for other places where critical strings leave the system. So I wrote sh template tag, and what that does, you write sh backtick. This is a tagged template. This is creating a string that looks like tar-tf followed by some file path. sh understands the bash and sh syntax, so it knows that in the top one, it needs to wrap tarball in quotes and escape it, unless it happens to be a have type shell fragment. And it knows here that it needs to escape it but not wrap it in quotes. And so we can have our tools be aware of the syntax of the messages that we're creating and compose nicely even when string inputs are untrusted. And this returns an sh fragment. So if we constrained ourselves, for example, on the node side, instead of using child process, we used a child process wrapper, or if we patched child process to check for sh fragments, then we could check the integrity of shell strings before they reach the operating system. And SQL injection can be managed the same way. I've got a patch before the MySQL maintainers that provides something like this. Again, it's a template tag that understands the SQL language and picks appropriate escaping conventions. So this kind of approach is particularly suitable to JavaScript because JavaScript is a glue language. JavaScript doesn't provide direct access to the outside world. Instead, you access the outside world through host objects. So JavaScript might be sending HTML to the DOM, or on the client side, it might be writing it to a request body. On the server side, it might be writing it to a request body. On the server side, it might be sending SQL to a database. It might be sending structured data to a web service or invoking a child process. By putting guards before messages leave the system, we can preserve the integrity of messages leaving the system, which means we have a way to say something about the side effects that happen. We can bound what queries get to the database because our SQL tag preserves the intent of the developer. If something looks like a single string or value in the query, then regardless of the value that goes in there, you're going to have that same structure preserved. And the same for HTML. If something looks like an HTML tag in our auto-escaping template language, it's going to be an HTML tag in the resulting HTML, and there aren't going to be any new script tags introduced. So we've been doing this for a number of years now. It's very hard to quantify the effect that you have on security. We do have some indicators, though. Google has a vulnerability rewards program. We pay security researchers to come to us with vulnerabilities they find instead of selling them on the black market. And so we've, for two products, I think this is Gmail and Google+, they both start with a relatively high rate of XSS. That rate was actually pretty good for web applications at the time, but we want to do better. So after a period where they're rolling out these techniques, the numbers drop off, and then they stay fairly low. So one thing to note is that most of the XSS kind of around the last couple years, which aren't actually shown on this graph, have been a result of bugs in my code or other people on my team. They're not bugs in application code. So a small amount of effort fixing those can actually improve security for a large number of products. But getting these techniques adopted can be hard. So that was the real failing of CSP. Besides the difficulty of crafting and maintaining narrow, secure policies, the other was really getting adopted. So we found somewhat counterintuitively that you can use continuous integration tools to drive adoption of these practices. So, for example, by hooking into a code review tool, you get access to a place where you both have artifacts, since oftentimes you plug into the code review tool to run tests and make those test results available to reviewers. You also are there when humans are discussing the changes. So here's an example of how this might work in practice. I can't play all these different characters, but a developer submits a patch. That kicks off a test run. We've instrumented the test runner to gather information about the program. So the test runner tells us, these modules loaded these other modules. If we've got fairly good test coverage, it doesn't need to be up in the 80s or 90s, then you know which modules tend to load which other modules. And once you've got, you know which modules load which other modules, you can start comparing that to previous runs. The continuous integration dashboard might look at a configuration file that lists APIs that are hard to use correctly. So these are APIs that do things like assign directly to inner HTML, or directly create child processes, or just APIs that come with a lot of caveats. Kind of, if you do this, then you must do this before doing this other thing. Or never do two of these at once. These kind of constraints. So we've got this set of APIs that we know often are involved in bugs. If we see that the patch adds a new use of that, or is in a module that uses one of those, or is one of those modules, or adds a use of those modules, then we can note that. And so what we do is we automatically loop in a human. So I spend every 4th or 5th week on call, where I'm basically just, my team is a small team that supports thousands of application developers. I occasionally spend a week where spend a good chunk of it just following up on requests like these. Somebody needs to do something that uses a sensitive API, 10, 15 minutes, look at it, figure out. Sometimes the answer is, you're using this unsafe API, but we've actually wrapped it with a safe API that provides a simpler, less error-prone abstraction. Might that work for you? Oftentimes the answer is yes. Sometimes the answer is no. If we happen to notice, but since we're in the loop, we stand in a place to notice common situations that aren't served by our APIs. Sometimes the answer is you have to use the unsafe API. I'll work with you to use that correctly. Then we'll record the fact that the module you're writing should have access to it. We can use that, we record that fact in revision control. It's just listing, authorized loaders of this sensitive API. We can instrument, if we want to get really strict, we can instrument the module loader so that in production, we lock down these sensitive modules and only allow kind of approved loads. But just looping in a human when sensitive APIs are used gives you a lot of the value. And I was actually talking to a couple people while I was finishing these slides, and now I can't get it out of my head. This is a graph with modules on it, even though it looks like a lot of very friendly sheep. So, for example, this module is using this module, which creates a contract value. So remember, we want to make sure that our values like trusted HTML are safe by construction. So we have to be very careful about how we go creating these. If this provides safe APIs, then we don't have to worry about this code. It's calling the safe APIs. If this is a sensitive API, then changes to this module now need to be checked, but we don't worry about other modules that use it. As opposed to CSP, which just treats your code as a bundle, a tag soup and JavaScript soup. By being aware of the module structure and by being involved in the type system and involved in programmer workflow, we have a lot more context to provide kind of responsive, adaptable security. And so, the promise that we provide is, if we can focus eyes on the critical code that creates trusted values, and we're correct about those judgments, and we control where messages leave the system, we check for appropriate types where messages leave the system, then we can preserve the integrity of the system. And so any security properties that hinge on preserving the intent of trusted developers and the end users based on the structure of messages that leave the system, regardless of the inputs that enter the system, then I think we've got a strong security story. And unfortunately, one of the things that we really loved about CSP was that it's simple. We get a number of talented browser developers to implement CSP. Application, security weenies like me write policies. We don't have to worry about the code too much, and suddenly everything's great. This does require a lot more work. So if anybody here is interested in doing things like, you have an idea for a contract type that solves a common use case, or you know of tools or are interested in updating tools to produce contract types and consume them, or you can do framework integration or with opt-in type checks at critical places. For example, changing response.write so that on a web framework it requires trusted HTML instead of arbitrary strings. Or you have experience writing hooks for open source continuous integration tools. I'd love to hear from you. If you have thoughts on developer experience, that's always useful too. I've been talking quite a bit about this topic. If you like capture the flag style security puzzles, tinyurl.com/secpuzz is a series of videos that I put out to explain common security pitfalls and how to address them comprehensively. My JSConf talk was a lot lower level than this. That was an attack talk where I demo 3 classes of attacks, and then how these practices can be applied to fix them comprehensively. And then I talked about, there's a bunch of Node-related stuff for the Node enthusiasts there. And if you're looking for kind of more in-depth source material, the best one to look at is Securing the Tangled Web. And if you have questions and don't catch me in the hall, feel free to look me up on Twitter. So thanks for being an awesome audience.
Thank you so much.
Thanks.